Okay, so we're given moles. I told you guys on Monday that for if you're given grams, then that's where you know where to start, right? Because we're going to go from grams to moles. Okay, well, in this situation, we're given moles. Okay, so it's really just one less step that we're going to have. So if we start with what we know here, oops. Okay, so our grams to moles, so we can just think of it as it's been done for us. Okay, so our first step is going to be what? What are we going to be looking at? Okay, so you're going to be looking at the relationship of what you're given, the calcium hydroxide. Okay, so it looks like our balanced equation, we have 1 mole. We're looking at our mole-to-mole ratio, and then we're trying to find HBr, right? So we have 2 moles HBr. So this first step is similar to the same as what we were doing the last unit. Okay, so now we're in units of moles HBr. So we've converted from calcium hydroxide to our acid here, hydrobromic acid. Okay, but we're asked for the volume. So we know we're going to have to plug in, so molarity is the same thing as moles over liters. Okay, we know that moles is going to have to be in the denominator, so they can cancel. So we have 0.558 moles in 1 liter HBr. So all I'm doing is plugging in this here. Okay, so when we do the math, 0.960 times 2 divided by 0.558 should get about 3.44 liters, bless you, HBr. Everybody get that? Awesome. All right, let me check and see if my attendance is working now. Okay, Justin, Anderson, Heath, Alex, Kumar, Mariah, Tyler Cook, Jesse Davis, Justin Davis, Yolanda, Jordan, Elledge, Robert, Tiffany, Andy, Daniel Lee, I don't know if I know who that is either, Jameson, Joey, David Peterson, Hayden, Alicio, Eric, Dylan, Wesley Russell, Josiah, Brittany, Clayton, Jennifer, Jesse Thompson, Taylor Thompson, Darius Troop, Anderson Young. Good deal. All right, so now we're going to look at chapter 14. So we're really just building on solutions. This chapter contains the most information, so a lot of definitions that we're not going to do today. We're going to kind of get the calculations and the equations out of the way first. That way you have plenty of time to practice those. Okay, so we're going to do that first, and then next week we'll kind of look at more definition type things and look at things called colloids and suspensions and all kinds of things like that. So, and osmosis will be another another topic. But today we're going to focus on concentration again. So we're going to look at a couple more ways that we can express concentration. Okay, so we started Monday, I think I asked the same question. So far, what are the two ways that we've learned to express concentration? Molarity, exactly, been using it a lot, right? Okay, and what's the other one? Percent by mass, yes. So even though that was on the last unit exam, it will also be on this one. Okay, so you want to be sure, we kind of ended with that. It was just kind of a segue into this, so be sure that you know all those. Also dilution, be sure you don't forget that one either. So M1B1. Okay. So today all we're going to really get to is ways to express concentration, and the rest we'll be looking at next week. So like I said, they're mainly more definition type concepts than calculations. Okay, so just to review here what you just told me. So percent by mass is one way that we express concentration. So we take the mass of the solute. Okay, can anybody tell me what a solute is? You can give me an example, anything, or the definition. Okay, sugar and sweet tea or in water, salt and salt water. Okay, so is it usually present in the most amount or the least amount? Least amount. So the more there is, the more concentrated, right? Okay, very good. And then it's over the total mass. So this is, again, just like part over whole times 100. Okay, you take part of the solution, the solute, and put it over the total mass. Okay, and so percent by mass, so you also have this symbol W/W is also a symbol for that, but your units need to be in grams. So the mass part should hopefully give you a hint on that. Okay, molarity, we've spent quite a bit of time on this. Okay, one thing I want to be sure that you see here is that molarity is moles of the solute, okay, over the liters of the total solution. Okay, it's not just the solvent, it's the liters of the total solution. Okay, so it takes into account the entire solution. And now we're going to introduce two more ways to express concentration. Okay, these can get a little bit confusing, so I want to be sure and go over kind of the differences here. Okay, we have molarity, and we also have something known as molality. Okay, so it's only different there by a letter. So you got to pay attention even on the exam that you're looking or you're solving for the correct way to express concentration. Okay, so the molality is this lowercase. So it looks like it's italicized really. Okay, but it's supposed to be the lowercase, whereas molarity is the uppercase. So you got to uppercase M, so you got to be careful there. Okay, it looks very similar to molarity in the fact that molarity is equal to moles of solute as well as molality. So molality is equal to moles of solute, okay, in the numerator there, but it's over kilograms of solvent. Okay, so whereas we were looking at liters for molarity, we were looking at a volume of solution, whereas here we're going to be looking at it in reference to kilograms of our solvent. Okay, does anybody remember kind of what the prefix kilo means? I think I heard somebody say 1,000, right? Okay, so if we think about, you want to be sure you can convert from kilograms to grams. So all you're going to be doing is moving your decimal place, depending on what you're being asked for, over 3 places. Okay, so it's 1,000th. So there's 1,000 grams in a kilogram. Okay, a lot of the time molarity and molality are nearly equal if they're in a dilute aqueous solution. Okay, but they are different in the fact that we're looking at the mass quantity here versus the volume quantity. Okay, so like we always do, we're just going to start with a problem to see how we would solve for this. So if we're looking for the molality, and I'll be sure to try to indicate, also put the lowercase so you're not just get nervous on your exam and kind of flying through, to be sure you don't get them confused. Okay, but molality is the lowercase m, and it contains, we're looking for the molality of a solution that has 108 grams of methanol. Okay, so methanol here is our solute. Okay, in 128 grams of water. Okay, 99% of the time, if water is included in the solution, it's going to be your solvent. Okay, so it's going to be an aqueous solution. All right, so we need to find the molality. So the first thing we have to know is we have to know our equation. Okay, but before we move on, make sure I make this point. Okay, the difference in molality and molarity is the obvious. So we're looking at kilograms versus liters for molarity. Does anybody notice another difference? Yes. No, we're still in moles in the numerator. We're still in moles there. Okay, that's the one difference. We're in kilograms versus liters. Okay, but there's one more difference. Exactly. Okay, this is kilograms of just the solvent. Okay, so if we look at this problem here, it's just of water, the mass of the water. It's not of the total solution. Okay, whereas molarity takes into account the total solution. Okay, so we'll work problems so you can kind of see the difference here in a few minutes. But okay, so moles is the same. So what are we going to have to do first to plug in for moles of our solute, which is methanol? Okay, we're going to convert grams to moles. So I told you guys that it was imperative that you know how to convert from grams to moles and moles to grams because we're going to be using it constantly. Okay, so okay, I want you guys to add up the molar mass just to be sure you get the same thing as I've got. Okay, so we have, look on the periodic table, we have 12.01 for carbon, 16 for oxygen, atomic weight, and then we have 4 hydrogens, which are about 1.01. Okay, so we should end up at about, I guess I went ahead and rounded. I just rounded to 32 there. Okay, it's always out of 1 mole. So we end up with about 3, 8. Okay, so now we have the numerator. Okay. Now for kilograms of solvent. So if we look up in our problem, water is our solvent. Okay, and we're just looking for kilograms of solvent, not of the total solution. Okay, so we have 128 grams, which is equal to how many kilograms? Exactly. So if we move our decimal, we get 0.128 kilograms. Okay, so if we divide 3.38 by 0.128, we should get about 26.4. Okay, and don't forget your units here. So molality, CH3, OH. Any questions on that one? Have to convert from grams to moles first. Plug that in. Then all we have to do, we're given grams, so all we have to do is move our decimal place over and plug it in. Okay, we're going to use molality, but you have to recognize. So if you're given this on the exam, you want to read through here, and it should, right here we have the lowercase m, so we have 37.0 molality solution of methanol. And now we're trying to find the grams of water. Okay, so basically we're just going to have to rearrange the equation. Okay, so if we look at our equation, molality equals moles of solute over kilograms. Okay, so let's look at what we're given. So we're given the molality. So we're given this. Okay. We're given grams of methanol, which we already converted to moles, so we know we can find moles. So our variable, or our x, is going to be the kilograms. Okay, so if we rearrange this equation, okay, we rearrange it. Go ahead and do that first. Okay, we get moles over molality equals kilograms. Okay, we're asked for grams, but we know if we find kilograms, then all we have to do is move the decimal place. Okay, so I kind of did these using the same grams of methanol. That way we don't have to keep converting from grams to moles. Okay, so if we look back at our problem, how many moles of methanol did we have in 108 grams? Okay, so we had 3.38 moles. Okay. All right, and we're given the molality. Okay. So when we divide 3.38 by 37, if I get 0.0914 kilograms of water, which is our solvent. But if we need grams, we're going to move it over 3 places. Everybody get 91.4 when you do the division here and move the decimal? Yes? No? Yes? Okay, good. All right, so just another way to ask this question. So just like most all of our equations, we can rearrange them and solve for a different variable. So you just want to be sure that you recognize this, so you know the equation kind of forward and backwards, that you recognize which equation to use. Sometimes that's the hardest part for students, to see, you know, what equation to use and then plug it in. Okay. So we have 3 ways so far that we've looked at to express concentration. Okay, we've got percent by mass, molarity, and now molality. Okay, so hopefully you're kind of seeing the differences in these and getting used to them. The 4th one is mole fraction. Okay, this is a dimensionless expression, so you're not going to have units. Unlike most of our chemical equations, most of our measurements, everything in chemistry, we have units. Okay, but for this, your units basically cancel each other. Okay, so you're going to have no units here. Okay, so don't be tricked if on the exam there's 2 answers that look the same, but one has units and one doesn't. Okay, the one that doesn't is the answer, right? Because this does not have units at the end. Okay, so the mole fraction, basically in its name, moles, you want to think everything's going to be in moles. So if you're given grams, you've got to convert to moles first. Okay, and basically it's the number of moles of one component divided by the moles of all of the components in the solution. Okay, so if we have a sugar solution, so we have sugar and water, and we want to know the mole fraction of sugar, then we have to find the moles, unless it's given to us, and then we divide that by the moles of the sugar plus the moles of the water. Okay, so the total mixture or solution. Okay, if you have more than 2 components, so you can have a solution where you have salt, sugar, and water. Okay, and then you would have to add up all the moles for each component in the solution. Okay, so it's just literally a fraction. Okay, so that's why it's called mole fraction. So another example when they actually name things and it makes sense. Okay, so you're going to take the moles of A. So we don't really right now, we're just looking at it just a general form. So if we're looking for the mole fraction of A, we take the moles of A and divide it by the moles of A plus B. And this would be an example if you just have a two-component solution, so sugar and water or whatever example might be. Okay, and then if you're looking for B, so say you're looking for the mole fraction of the water instead of the sugar or whatever our solute is, then you just take the number of moles of B and divide it over the number of moles of A plus B. Okay? And when you do this, I may ask you for the mole fraction of both components, or I may just ask you for one. But if you do it for both, when you add up the mole fraction, so both of your answers here for A and B, it should equal 1. Okay? If it doesn't equal 1, then you've done something wrong there. Okay. All right, mole fraction is given the symbol X. Okay, and we're looking for, so I usually put whatever the compound is that I'm trying to solve for, kind of as a subscript there. Okay, so we're looking for the mole fraction of methanol and water. So we're going to do both, okay, in a solution containing 108 grams of methanol. So once again, I just use the same number there so we don't have to keep calculating moles. And 128 grams of water. So we just have two components in our solution. We've got our solute and we've got our solvent. Okay. So the first thing that we're going to do is we're going to take the moles of methanol, which we already solved for previously and got 3.38. Okay, so all we did was we took that 108 and divided it by its molar mass to get the moles. Okay. All right, so now in the denominator we have to put the moles of both components added together. Okay, so we're always going to have our 3.38 also included here. Okay, but now we need the moles of water. So if we look here, we've got 128 grams of water. Okay. Water has a molar mass of about 18. Okay. Oxygen is 16, and each hydrogen is 1. So grams cancel. Left with moles, it looks like I have 7.11. Okay, so that number goes there. Okay, so we add up 3.38 plus 7.11 and divide that into 3.38. Okay, so we should end up about 0.322. Okay, and once again, we have no units. You want to be sure, I will count off not a whole lot, but a little bit if you do not put your units for the other ways to express concentrations, or really any of your problems at this point. You guys should be using your units and showing me those. So whatever you're solving for, your final answer, you should have units there, okay, except for with the mole fraction. Okay. Now we're going to find the mole fraction of water. Okay, so we're looking for this. Okay, so I'll give you guys a second. So find the mole fraction of water. And then when you get your answer here, you should be able to add up those two, and you should get 1. So you can really do it without even working it out, but for practice, work it out. remember your two numbers should equal 1. So okay, so we have 7. Okay, so whatever you're trying to solve for, that number of moles goes in the numerator. Okay, and then we should have the same number, right, in the denominator because we have two components and we always have to have the total moles there. Okay, so we have 3.38 plus 7.11. So we should get about 0.678. And those two numbers added up should be about 1. In the lab, we usually use molarity. We also use something called normality. It's kind of the old way to express concentration. It's not even in you guys' book, but Miss Janice and a few others, that's what they learned growing up. So we do have normality and molarity. And in the lab, when we hit that point, I'll actually kind of go over normality with you, but it is kind of the old way, so I don't really require it for exam purposes, but we will look at it that way you know what you're doing when you're in the lab. A lot of times normality, so this is basically a fifth way. Okay. A lot of times molarity and normality overlap, so they end up being the same. So, but we'll look at that in more detail in the lab. We do use percent by mass. We may have like a percentage of sodium hydroxide, so we do have, you'll see that labeled on containers in the lab. You'll see molarity. You will not see molality a lot for you guys, but we do use it later in Chem 112. It's usually used for when you have gases in solution, so it's looking at kind of the partial pressures and the concentrations, but we don't use it a whole lot for you guys. We don't really do any experiments like that. So. Okay, so now we're going to put all these together. You're going to have, there's a practice test, so it's got a problem that looks very similar to this. On the exam, this will be worth about 25 points. So you're going to have a problem. You're going to be given either, your solute and your solvent, and you're going to have to go through and you're going to have to solve for all 4 ways to express concentration. So this should be no surprise. There's really no tricks here. The only thing that we haven't gone over is if we are given a density. Okay, so you're going to run into, when you're looking for molality, I want you to kind of hit this, some of you may automatically know what to do, but a lot of you won't. I want you to kind of hit this point and be, kind of curious or ask questions. What do I do? I can't do this because of a certain reason. So I want you to see that, so I'm not going to show you at this point. Okay, we are going to start it off together, so we're going to look at the molarity, and then I'm going to kind of have you guys to try to finish it out. And of course, we'll go over and ask me questions and that kind of thing, and then we'll go over it. Okay, but you are going to have to use density. So remember, our units here are very useful because we have a grams and we have a mass and a volume for that unit. Okay, so that's going to become useful for us. Okay, so we have 25 grams of sucrose, and we have 525 milliliters of ethanol. Okay, so ethanol is our solvent, so you want to be sure that you recognize this. And sucrose is our solute. Okay, and now we need to go through and calculate. So those of you that don't have these printed out, you probably want to, I'm going to move slides, so be sure you have this copied down, or at least the numbers here. Okay, and the density is 0.785. I can probably fit the molarity down here, but okay, the first one is moles per liter. Okay, so molarity. All right. We're given that we have 525 milliliters. Okay, so 3.525 liters. Okay. And now we need to find moles of sucrose. So we know we have 25 grams So I want you guys to add up the molar mass here. You've got 12 carbons, 22 hydrogens, and 11 oxygens. Be a pretty high number here. Okay, anybody else get about 342? Okay. I got 0.34, but just depends on. So you have 12.01 times 12, 22 times 1.01, and 16 times 11. Some tables have 15.999, so I mean you might get a little bit, vary, but just as long as you've got at least the 342 there. Okay, so go ahead and divide and tell me what you get for moles of sucrose. Anybody? 0.0730. Okay, so now we can plug that in. So we get about 0.134 molar solution of C12H22. Okay, so once you get this one down, try to work molality, mole fraction, and weight percent. And at this point you may have to look back, look at the formulas, be sure you're plugging them in correctly, so that's part of practicing, but you do have to know these formulas, so I won't give them to you on the exam. If you finish this quickly, 2 more of your homework problems are number 26 and 32 in the book. I believe they're on page 544, I would say. Yeah, they start on page 544. Okay, 32 is a little bit more challenging, so at some point we'll go over it. Made today. Just 26 and 32. Yeah, because they all look like this. You've got like 4 parts to each of them. While I'm doing this, raise your hand if you've not taken exam 2. Anybody in here? I'm almost positive everybody has, but be sure. Okay. yours already? Okay, how is it going? How's molality? Everybody figure it out? Not quite? Okay. What's the point to that? Yep, you got to use the density. Very good. Okay. That's going to take entirely too long. We're just going to go like this. Okay. We already did A, so this one's actually B here. Or molality. I'll just, there we go. Okay. All right, so molality is equal to moles of solute over kilograms of solvent. We already found moles, so that's why I like to do these problems kind of all together. That way you're not having to solve for moles over and over again. So hopefully we can all do that at this point. So we get 0.0730 moles. Okay, so that's of C12. Okay, so here's where you might have run into a problem. Okay, so in the problem we're given that we have 525 milliliters of ethanol. Okay, so we have a volume where in molarity this was fine because we could just convert from milliliters to liters. Okay, but now we need to go from a volume quantity and go to kilograms. Okay, so in order for us to get from one totally different unit to another, we have to have some kind of common relationship. There's got to be a way to convert, to get from milliliters to grams or kilograms. Okay, so this is where we're going to use density. So we have to use that value given, so it does have a purpose. Okay, if we look at our units there, it's grams over milliliters. Okay, so that's considered to be 1 milliliter down here, and 0.785 grams. Okay, so we want our milliliters to cancel. So it ends up being, like Anderson said, 525 times 0.785. That gives us 412 grams, which is also the same thing as 0.412 kilograms. So we plug that in. should get about 0.177 molality C12, CH22. Anybody get that? Awesome. Okay, any questions? So there's just that additional step. If you are given the volume, but you have to get to a mass quantity, grams or kilograms, you're going to have to multiply times the density. Okay, so we're looking for the mole fraction of sucrose. So we're not really asked for the ethanol in this problem. We're just looking for mole fraction of sucrose. That should really be. Okay, so I know we just went over this, but if you had to look back or whatever, so what are we going to put in the numerator? Going to go there. Okay, the moles. Everything in this problem is all moles, and in percent by mass, everything is in grams. So that's one way to remember. So we've got our 0.0730 moles. What we're trying to find here, the mole fraction of. And then we know that's going to be in the denominator too, because we have to add up all of the moles. Okay. But now we need, so we've got moles of sucrose. We need moles of, sorry, it's just abbreviation for ethanol, ETOH. Okay. All right, so where can we go? What can we use from our previous calculations to help us here to find moles? Okay. All right, we need to find moles of the solvent, right, of ethanol. Okay, so in part B, before, when we multiplied our density times the liters, we found grams, right? Okay, we found 412 grams. Did everybody see that from the previous problem? Okay, so we already have our grams. Okay. So we can add up the molar mass of ethanol. So you should get about 46.08. Okay. So grams cancel. We get about 8.94 moles Okay, so that goes here. So if we add up 0.0730 plus 8.94 and divide that into the sucrose, you should get about 0.00810. Okay, and if you want to check your answer, you can go and go ahead and find the mole fraction of the ethanol. And when you add those two numbers up, so the ethanol should obviously be a much larger number than for sucrose, and they should equal 1. Any questions on this? Yes. Yes. This right here? Okay. It's shorthand for ethanol. Yeah, it's just ethanol. Okay, has anybody gotten to weight percent yet, or percent by mass? Okay. What did you get, Andrew?
I got 5.72%.
Very good. Okay, very good. And you really just have to have we're looking for the percent of sucrose, so you don't have to even do the the second part, but okay, I'm just going to delete this. All right. So where'd you start, Andrew? What'd you start with? Okay, so we have to take our part over whole times 100. Okay, so in the problem we're already giving grams, so we just plug it in. Okay, and then it's over the mass of the total solution. So if you're given two separate components, you have to add those two up. So you've got 25 grams plus you have to take into account the mass of the ethanol, which earlier we calculated to be what? Yep, exactly, 412 grams of ethanol. Okay, you have to be careful how these problems are worded. So in this one, it's obvious we have two separate masses, so you add them together. But if it was to say you have a 100-gram solution, that means that your total solution has a mass of 100. Okay, so you have to be careful. You wouldn't need to add anything else to that. So be careful how it's worded, whether it's giving you the separate masses or if it's giving you the total mass of the solution. Okay. All right, so ended up getting, what did we say, 5.72%. And this would be of sucrose. Okay, an example of what I was just saying here would be if you had something that said calculate, I'm just going to write it up here, calculate the weight percent, percent by mass, either way it's asked, weight percent of sodium hydroxide in a 30-gram solution containing 6 grams Okay, so this time we're looking for the weight percent by mass here. Okay. And we're given that we have 30 grams of a solution that contains 6 grams of sodium hydroxide. Okay, so which component is our solute? The sodium hydroxide, right? Because our solute is what's present in the smallest amount. So we're given in already grams, so that's going to go in the numerator. So we have 6 grams. Okay. And we're told we have a 30-gram solution. So we're going to place 30 here. Or are we going to place 30 plus 6? 36 here. 30, exactly. It tells us the mass of the solution, so there's no need. So it's already taking into account that 6 grams from the NaOH. So we would just have divided by 30 times 100. And we get about 20%, I believe. 20%. That's an H. Doesn't look like one, but it is. Okay, any questions on these so far? All right. Okay, so number 26 and 32. So we'll be working on those. Like I said, 32 takes a little bit more challenging, just a couple things that we haven't really quite looked at exactly yet, so definitely go over those. But encourage you to stay and do these problems, so stay and do them till class ends, but I know I say that and it really doesn't matter. You're going to leave anyways, but I'll be here if you have questions. But otherwise, y'all have a good afternoon. Do what? 5:44, I think. Yeah, and these are part of the homework, so I encourage you to do them. Also, if you have questions on your exam, a lot of you need to work on those. I think starts at 5:44. Yeah, number 26.